Okay. Now it's correct. There is one more charge, some point. So this distance will be R, which is, let's take this as R1 bar. So R will be equals to R minus R1 bar, a vector, R1 vector. Okay, let's write few points about this one. For a linear charge, dq equals to, what is dq? This one. Lambda dl. Now, what do you mean by this lambda? It is, do anyone know this? What's lambda? Charge per unit length. Lambda is charge per unit length. This is for linear. For surface, dq equals to same way, sigma ds. In short, see what we are taking. Lambda is what charge per unit length, and this is what integrated throughout the length. Similar way, it will be integrated throughout whole surface for surface. Linearly means length, surface means the area, throughout the area. The next will be volume. So what is sigma here? Charge per unit area. For a volume charge density. Let's write here distribution, surface charge distribution, and volume charge dq equals to rho dv. ds is that area, chota area. dv is that volume, small volume. Then what is rho here? Can anyone tell me what will be the rho? Varsha, what will be the rho here? Not
dq by dv.
Yeah. I'm not asking formula. Yeah, that is correct. But where? See, here we wrote sigma as charge per unit area. So that rho will be charge per what?
Unit volume.
Exactly. Charge per unit. You write till here, I'll just come with my book. And we'll do some numerical. ठीक है, डन. Shall I scroll?
Yes, sir.
Next is electric field. Okay, now what is electric field? A region, simple way if we say it's a region. So electric field strength at any point on the electric field is a vector quantity. It's a vector quantity. Let's directly write this one. In an electric field is a vector quantity. But what is it? It's a vector quantity, yes, but which is equals to what? A force acting on it. Suppose we are taking some test charge here. So, what is test charge, by the way? When we are taking one charge here, okay, assuming one charge here, which is falling on some object or some other charge. So then we'll calculate the values according to that one. So that charge, suppose, let me draw here. Suppose this is charge 1 and one charge, let's name it as Q0. It's brought nearby this one and brought nearby 2. So how it is affecting that, we will see accordingly. Like we will calculate those things and we will see that what's the distance kept and how was it. So is it positive, is it negative, whatever. So this charge is a test charge which is testing for what is the charge for Q1 and what will be at Q2 and how it will affect the other charges. That is the test charge. Suppose unit positive test charge. Exactly. So test charges are small and positive so that it don't cause any deflection in electric field. Yes, it is. That's why it's just for specially for testing. That's why they gave a name as a test charge. ठीक है? And what will be the direction? Same direction in the force it is. You can write there in your own words. Along. Force. In the direction of force. Done this writing?
That's
Am I audible properly, right? Is my audio is lagging?
no, sir.
Then let's write about this one. If F is the force, so it is F is a force acting on this small positive test charge. Positive test charge. That is Q. So electric field on this one will be equals to force by Q naught. Okay, so what we defined just now, let's see. What did we define just now? Electric field strength at any point in an electric field is a vector quantity whose magnitude is equals to the force acting on a unit positive test charge and the direction along the direction of force. Keep in mind. So with this one, we can make one formula. Limit Q naught tends to 0. So unit of electric field will be Newton per coulomb or volt per meter. Newton per coulomb or volt per meter. So these are SI units of electric field strength. Can you remember this?
Yes, sir.
So now find out force, or not find out force, substitute this force value from the graph or this diagram. There will be one Q and Q naught. F equals to K Q1 Q2 by R square. So substitute those values, and what will be the E here? Tell me. Quick. Substitute force value, force equation. Remember, right? Monday we derived.
Sir,
Yes.
is it K Q1 Q2 by R square into Q naught?
Into 9 divide by. See, we have E F by A. E equals to F by A. Q naught.
Yes, sir. Force is K Q1 Q2 by R square. No, sir.
Yeah. K
R square in that
Q naught by. I'm sorry. Your voice was breaking. I couldn't hear. Please repeat again.
Sir, as this R square is like F is equal to K Q2. So
Yeah.
equals to F by Q naught. So F is equals to Q2 by square means E is equal
Hold on, please.
to
Seriously, your voice is breaking. I couldn't hear you. Do one thing. Type it. Voice is literally breaking so much. I couldn't hear properly. Please type it so I can read and understand what you're saying. Okay, so till then I'll write here. Let her type. Huh. That is true, right? K Q1 Q2 by R square into Q naught. But here Q2 is our Q naught and Q1 is Q. So we can say 1 by 4 pi epsilon naught Q by R square. Let's take it as mode. We'll take positive value of this one. Is your doubt clear, Adesha?
Sir, I was saying that.
Oh, okay. I couldn't hear it properly. Yeah, now you're audible, but still somewhat disturbance. Have you suppressed your background noise? Yeah, Zoom meeting.
Yes, sir.
Off it. Make it auto. That might be okay. Okay, so this one, what we wrote, let's write in detail properly. I was just simply deriving. So let's write here first one, electric field strength Q2 point charge Q at a distance R. So that's what we got here. F by Q naught equals to 1 by 4 pi epsilon naught Q by R square. Same thing you're writing, no need to erase what you wrote. We just gave a heading. Second one. Or let's write in a vector form first. Now how to write in vector form? Ditto same what we did before, same thing we are going to do. Come on, start doing. One by 4 pi epsilon naught Q by R cube R vector. Because for unit vector, it is equals to R by R cap, R vector. It's R. See, we already derived here. Remember? Where is it? I guess so here. R cap equals to unit vector R cap equals to R vector by R. ठीक है? Then let's write second one. Anything left here? Vector form we wrote. Okay. So the electric field strength due to a system of discrete charges or some number of charges. Discrete charges. One by 4 pi epsilon naught, same way. Summation of I equals to 1 to n qi ri cube ri vector. Position. For a system of discrete charge. The electric field strength due to continuous charge distribution. If it is continuous anything, now if you remember in 11th standard, we have not we means we have studied like UDL and VDL, like a uniformly distributed load, right? So whenever there is a uniformly or continuous distribution, what we'll do, simply we cannot add, we have to integrate. So integration of this we will do. Make a note of this one, come on. Then
Done, sir.
right, we saw these things. Now let's see few more things. Okay, first let's recall what is charge. Can someone recall me what is charge? Quick. What is charge? What do you remember? No? Adesha, what is charge? We are talking about so much about charge. Do you remember what is charge?
सारे कीड़े सारे हाँ
Are you answering something? Okay. Fine. Whatever. Okay. So let's know something more about charges here. Method of charging. First one. Charging bodies by rubbing or friction. Property of matter which is due to charge. So if you want to know some wordings, let me write here. It's not about this one. I'll erase it. We can say simply charge is a property, as you wrote already. You wrote, Adisha wrote already in this one. Property of matter due to which it experience what? Electrostatic force. Experience electrostatic force. Okay. So for what? Attraction and repulsion. See, if I ask you again what is charge, you should answer this way. Your answer is correct, Adisha, but some wording. Okay? Use some good wordings like this. What is charge? Charge is a property of matter, what you wrote already, which produce electric field due to its charges. Yes. Will also correct. Use some wordings like this. Okay, Adesha?
Yes, sir.
Okay, correct. So for everyone, remember this way. We are not in like a junior school. We are now in 12th standard. If we have to improve our wordings. Answer is same. To improve our wordings. So charge is a property of matter due to which it experiences electrostatic force of attraction and repulsion. Or even you can write some Google answer. It will be like some intrinsic property and blah blah blah. They will say it is also correct. All answers are correct. Okay, let's come back. Charging a body by rubbing or friction. Okay. So suppose when two bodies are rubbed together. Okay, what happens when two bodies are rubbed together?
So transfer
Exactly. Transfer. Transfer of electrons. Yes. That's what you say, right?
Yes, sir.
So when two bodies are rubbed together, the friction between the bodies causes transfer of electrons from one body to another. And as a result, both body, not body, it's a plural, both bodies become charged. Let it be positive or negative, doesn't matter. But it becomes charged. So condition is here, the body which loses, it will be something, which gains, it will be something. What is that something? Yes, yes, say. Varsha?
Yes, sir.
Can you hear her? Adesha, can you hear properly? Or is
No,
it-
sir, her voice is lagging.
Okay, I thought because of I have internet issue. I thought okay, you wrote something. Let me see if you answer. The body which loses electrons becomes oh yeah, she wrote something. Yes. Yes, exactly. Positive and gains negative. Very good. Positively charged and electrons become negatively charged. Now, let's write some example with this. Once you finish writing, let me know. I'll write example here. See, I'm writing so big, so because some of you are using phone. So you should strain your eyes. Done? Okay. Give me one example. Varsha, give me one example. Adesha, you can send me in chat box. Dhairya and Mohammed Jafar. One example, please. Come on. Quick, quick, quick. Yes,
Sir,
Varsha.
sir, a metal sphere and glass rod or plastic.
Yeah, exactly. Rubbing those things, yes. Dhairya, one example. Yes, example, glass rods, cloth, rubber together, pull and you can I together. Yes. Very good. Example. Rubbing glass with wool or fur. Okay, in short, what is this process called?
So could you repeat your question?
What is this process called? What we wrote just now, charging body by rubbing or friction. What is this process called? One general term.
Frictional.
So is it frictional?
Frictional. Okay. Glass rod and fur is positive for our convenience. See, these things we are assuming that this is positive. Actually, it can be either case, opposite also. But for our convention, we charge on glass rod and fur, we are taking as a positive. I'm not able to find. Yes, dear.
Work function will also be a reason.
What function?
Work function.
Yeah.
For glass rod and fur.
Exactly. How we are rubbing it, that also matter. How the work is done on that, it also matter. But just for convention, we are using this one. Okay, silk rod and what is this? Another one? Plastic here. This is for our convenience. Second one. You have time, right? Yeah. Charging by touch. Yeah, before starting this topic, one more thing I want to tell you. See, this Friday and next Monday, I won't be able to take your class, but test will be that on Sunday as usual. It will be from the first topic. I already said, right? Did I inform this? For test, that it will be from the first topic, that is on the units, dimension and all that. Measurement. Including measurement, okay, error and all that. I think I did inform this one to you, right? Okay. So Saturday you prepare, sorry, no, not Saturday, Friday I won't be conducting class 99%, but if I'm taking, okay, I'll inform in group itself. So on that day you make preparation for, on that time you prepare for this test. Got it? Don't waste time. Because I will search some good question. I'll prepare some good question and send it. It will be difficult, not that easy. That also difficulty level up to you how much you have prepared. But prepare the first chapter. That's what I mean. Clear with everyone? Varsha, did I inform this one priorly? Have I informed this one?
Yes, sir.
I think so. Last class only I informed, right?
Yes, sir.
Okay, then let's go for charging by touch. When a charged body is made to touch an uncharged body, some of the charge from charged body, what happens to this? It is transferred to the other body. This is called charging by touch. Third one, charging by induction. Yeah, by the way, you understood this one, right? Is it easy English? Understandable? Or shall I make it more easier? When a charged body is touching the uncharged body, what will happen that time? The charges from charged body will be transferred to the other body which is uncharged to balance that. That is called charging by touch. First we saw charging by rubbing or friction. Second we saw charging by touching. Now third one is charging by induction. Now suppose let me draw a standard example. I think so this will be there in your book too, your textbook. So here B. Okay, let's consider two sphere A and B, and the stands are insulated. The stands are insulated. Why insulated? So that it won't be affecting our process, whatever we are doing. And bring them together. This is a metallic sphere. We didn't say it's a charged sphere. We said two metallic sphere. Now, if we bring some charge rod or something, let's take as positive. Near the A, that is on left side, left end of sphere A. See, we are not touching. We are just bringing nearby. Let's draw a rod here. Now, what will happen if it is bringing near A? What will happen here on A?
Negative charges will get accumulated on that side.
Exactly. Negative charge started accumulating on A near to this rod. And what will happen to remaining positive charge? They will move away because it's repelling. Right? Repulsion and attraction, very simple. Clear? So in short, what's happening here? Both rod or both spheres become charged. Now, if you remove this one, we are not going on further. If we remove this rod, then there will be some charge in A, and there will be some charge in B. Right? Both spheres will have some charge. So This process is called induction, inducing charge without touching. Some conditions here, not conditions, we can say some like note for this one. You can say both sphere have same charges, equal number, not same charge, equal and opposite. Opposite charge. Then some more thing we can write here. Some electron means not every electron will be moving, but some electron. Let's write here not all electrons in sphere accumulate on one side, because as electrons keep accumulating in some position, right? Accumulated the strong repulsive force from already accumulated electrons. So what happens here? They will become in a equilibrium state, so that no attraction, no repulsion after this. So they will be means like they will be in equilibrium state at some point, because there cannot be more and more electrons be going inside, because there some electrons already are there which was priorly induced. So they will, once it gets stronger and stronger, so it will start repulsing the incoming electrons. Okay. Okay. Anyone having doubt today?
So last point I didn't understand.
Okay. See, as we drew here, suppose negative, forget this B part. B part is not there. We are just inducing on A. So negative is induced. Keep on inducing. Okay. Now some more negative electrons are traveling here. So already present some negative electrons. We have some, and suppose at some level it will start repulsing. That the repulsion force will be more than this force which is incoming. So they will start repulsing them because both are negative. So it will start stopping them. Don't come now, enough, no space for you. That means there is a equilibrium state. It will be at some point. There should be equilibrium at some point. Otherwise, there is infinite negative charge will be incoming. So after some point, there will be an equilibrium state. In short, what this big statement says, they will become at equilibrium state after few points, or not say few points, after some point. At some point, it will be in equilibrium state. Not much electron will be traveling after that. Okay?
Okay, sir.
Or we can say some other way, like after some time, they will set up some force of attraction and there will be opposing force of repulsion. So they will both do together, so it will be in equilibrium.
Okay, sir.
Yes, we can do induction process in 3 steps, right, by earthing. Yes, we can do it. Yes, yes. See, when we have studied in 10th standard, somewhat like induction, right? How to mutual induction, then some what are the other way? Magnetic induction, yes, right? So by they are not touching anything, still they are producing or inducing current. So by mutual induction. Okay. Okay. Shall I stop sharing? Have you written this?
Yes, sir, done.
Then, Varsha,
Yes, sir. Done.
Tairia, Jafar. Okay. Bye bye. Bye everyone.